Assalamualaikum warahmatullahi wabarakatuh, and hi everyone, my name is Dr. Muhammad Azrin bin Ahmad and I'm from Center for Mathematical Sciences. By the end of this video, you as a student should be able to find vector equation, parametric equation and symmetric equation of a line, and last but not least, you should be able to solve problem related to lines. Before this, when we try to discuss about lines in two-dimensional coordinate system, you have been taught regarding equation that represent lines in two-dimensional coordinate system, such as y is equal to mx plus c, where you should be able to determine what is the gradient and what is the y-intercept so that you can form equation of a line in two-dimensional coordinate system. But that is not the case for lines that exist in three-dimensional coordinate system. As you can see from the slide presentation given to you, we are going to apply the knowledge of vector in order to determine equation of lines in three-dimensional coordinate system. But you can use the same approach when you try to determine the equation for lines in two-dimensional coordinate system. As you can see from your screen, we would like to determine the equation of line L, which is the red line, and we are going to apply knowledge of vectors to determine the equation of this particular line. So basically, you have to remember when it comes to the description of this problem, we have given to you the formula which is the vector and parametric equation of a line. But in this video, I would like to tell each and every one of you how the formula is formed, because if you understand the formula, you should be able to solve problem related to lines in three and two-dimensional coordinate system. Alright, so right now, let's imagine there are 2 points that lies on the line L, which we will call those points as point P naught. And point P naught consists of coordinate x naught, y naught, and z naught. Then there is another point and we call that point as point P, consists of coordinate x, y, and z. Right now, before this in chapter 2, we did discuss about not opposition but position vector. So when I'm talking about position vector, I'm always refer origin as one of the reference point. If I'm asking you to determine the position vector of point P naught, by right, you should know that I'm going to determine vector OP naught. Okay, vector OP naught can be obtained by using this form, such as coordinates, respective coordinate at point P naught minus the respective coordinate of the origin. So I'm going to have x naught minus 0, y naught minus 0, and z naught minus 0. And the components of position vector OP naught is as simple as x naught, y naught, and z naught. And if I can find position vector of point P naught, I can always find position vector of point P. And position vector of point P is as simple as OP. And by finding the difference in terms of x coordinate, y coordinate, and z coordinate, you should be able to determine component of position vector OP. So I'm going to have x minus 0, y minus 0, and z minus 0. And the component of position vector OP is as simple as x, y, and z. Alright, so right now, if you see clearly the figure which I have illustrated together with you, I can always find another vector that connects between point P0 and point P, which lies on the line L. So I'm going to call it as vector P0P. According to what we have learned regarding vector in chapter 2, we did learn about triangle law of vector addition. For example, I'm going to have A, B, and C. As you can see from here, according to triangle law of vector addition, vector BA plus vector AC will produce vector BC. Okay, by using the same approach, vector OP0 plus vector P0P is equal to vector OP. Alright, according to the illustration given in the slide presentation, we will label position vector OP0 as vector R0, meanwhile position vector OP as vector R. So I'm going to have vector R0 plus P0P is equal to vector R. Alright, or I can simply have vector R is equal to vector R0 plus P0P. According to the illustration, vector P0P is labeled as vector A. So I can have R0 plus vector A. And then, according to the explanation given in the slide presentation, you can always find a vector that is parallel to vector that lies on the line L, and then we will call it as vector V. If vector A parallel to vector V, you can reach to this relation, such as if vector A parallel to vector V, hence you can have this expression such as vector A is equal to T vector V. By replacing vector A with T vector V, I'm going to have vector R0 plus T vector V. By expanding and write it according to the components, such as vector R is represented by elements X, Y, and Z, and equal to X0, Y0, Z0 plus T, and components of vector V is given as A, B, and C. So by comparing in terms of component, I will have vector X, not vector X, X is equal to X0 plus AT, Y is equal to Y0 plus BT, and Z is equal to Z0 plus CT. So this equation, we will call it as vector equation of line. Meanwhile, we will call this form of equations as parametric equations of line. Since each parametric equation, they have variable t, by letting t as the subject of your equation, you will get this symmetric equation of a line that consists of x minus x0 over a equal to y minus y0 over b equal to Z minus Z naught over C. Okay, so this is how symmetry equation of a line, parametric equation of a line, and vector equation of a line is formed. Now, let's take a look at this example where the author asks you to determine the parametric equation and symmetry equation of line L passing through point P that consists of 2, 4, and -1, and at the same time parallel to vector V, which is 4, 5, -7. And at the same time, the author asks you to determine another 2 points that lies on the line. Right now, what you should do is that you have to recall the vector equation of a line, because if you are able to recall vector equation of a line, by right you should has no problem to determine parametric and symmetric equation of a line. Right now, according to what we have learned earlier, vector equation of a line is given as vector r equal to vector r naught plus t vector v. And according to our understanding, in order to determine vector equation of a line, you should know what is one of the point, at least one point that lies on the line, and at the same time vector parallel. And in this case, all the information is given to you. As you can see from here, this line will be passing through a point P. Therefore, from that point P, you can get R naught. So, from point P, position vector R naught is known as 2, 4, -1. And at the same time, the parallel vector is given to you, such as vector parallel is 4, 5, and -7. Alright, what should I do right after this? I have to put it into the vector equation of a line, such as vector r is equal to 2, 4, -1 plus t 4, 5, -7. Alright, from here, the question asks you to determine parametric equation of a line. Therefore, parametric equation of a line is equal to 2 plus 4t y equal to 4 plus 5t, and z is equal to -1, -7t. So, you have done with parametric equations of line. And then, you have to search for symmetric equation of a line. Symmetric equation of a line can be obtained by letting t as the subject of your equation. Therefore, t is equal to x minus 2 divided by 4 and y minus 4 divided by 5, and also z plus 1 divided by -7. So, this is symmetric equation of line. Alright, the author also asks you to determine another 2 points that lies on the line. Based on our knowledge, or if you understand the question correctly, you cannot choose t is equal to 0. So you have to play around with the value for the parameter t, because it will help you to determine another points that lies on the line. So in this case, you cannot choose t is equal to 0, because if you choose t is equal to 0, you will get back point P, which is 2, 4, -1. So you have to choose other value for parameter t, such as you can come across with t is equal to 1, or with t is equal to 2, or up to t equal to 1000. But if you are in your right mind, you will choose, you cannot choose t is equal to 0, because you will get p back to 4, -1. Instead, you can choose t is equal to 1, And then you can simply substitute into the parametric equation, then you will get x coordinate, y coordinate, and z coordinate of a point. So in this case, I will get 2 plus 4 times 1, which is 6, when t is equal to 2. Okay, t is equal to 1, I'm going to focus one by one. So x is equal to something, which is 6. Y is equal to 4 plus 5 times 1, which is 9. And z is equal to -1, -7 times 1, which is -8. So you will get 1 point. 1 point, which is 6, 9, and -8. So you can choose t is equal to 2 in order for you to get another value or another point that lies on the line L. Alright, now let's discuss about this example. Okay, let's read the question. The question asks you to determine the parametric equation of the line L passing through 2 points such as point P and point Q. And at the same time, the author also asks you to determine what is the point of intersection between the line L and XY plane. So right now, you have to answer the question one by one. The question asks you to form a parametric equation of a line passing through 2 points. So according to what we have understand earlier, in order to form vector equation of a line, you need to recall back the formula such as vector r is equal to vector r naught plus t vector v. So as what we have agreed earlier, you have to find at least a point and also vector parallel. So in this case, we have to search for vector parallel first. So vector parallel for this particular line can also become vector that lies on the line. So since we have 2 points that lies on the line, which is point P and point Q, therefore vector V for this particular question is as simple as vector PQ. And in this case, you have to search for point Q minus point P according to the coordinate, which is x coordinate with x coordinate, y coordinate and y coordinate, and z coordinate with z coordinate. So in this case, I will get 2 minus 1, 4 minus 2, and -1 minus -3. So I will get 1, 2, and 2. 1 to 2 components of vector PQ, which is our parallel vector V. Right now, what should I do right after this? I need to find a point that lies on the line. So in this case, you can either choose point P or point Q. So I'm going to choose point P as one of the points that lies on the line. Okay, from point P, vector r naught is equal to 1, 2, -3. Then you have to put it into the equation or into vector equation of a line, and then you will get vector r is equal to 1, 2, -3 plus t vector v 1, 2, 2. And then I will get 1 x equal to 1 plus t, y equal to 2 plus 2t, and z is equal to -3 plus 2t. So what should I do right after this? The question also asks me to determine the point of intersection between this line L with xy plane. When it comes to three-dimensional coordinate system, there are 3 coordinate planes such as xy plane, xz plane, and yz plane. Based on our knowledge earlier, in the beginning of chapter 3, On xy plane, there is no variable z. Therefore, you can always assume z coordinate will become 0 on xy plane by assuming z is equal to 0, negative 3 plus 2t is equal to 0, 2t is equal to 3, and t is equal to 3 over 2. Right after you know what is the value of t, then you can substitute the value of t is equal to 3 over 2 into parametric equation x and y to determine x coordinate and y coordinate. In this case, x is equal to 1 plus 3 over 2, and your final answer would be 5 over 2. And y is equal to 2 plus 3 over 2 times 2, then I will get 5. Therefore, point of intersection between line L and xy plane is 5 over 2, 5, and 0. As simple as that. Before this, we have discussed on how vector equation of a line is formed and how to solve problem related to a line. But this time around, we would like to study the characteristic between lines in coordinate system. In two-dimensional coordinate system, lines can either parallel to each other or intersect with each other. When it comes to lines in three-dimensional coordinate system, there are three possible cases that you need to put into your consideration. As you can see from the illustration, line can be parallel to each other, intersect with each other, or neither parallel nor intersect, which we call them as skew to each other. There are mathematics way in order to show whether the lines parallel to each other or skew to each other or intersect with each other. Let's take a look at question B. Okay, you are given with two equations that represents two lines in the same coordinate system. Okay, L1 as x is equal to 2 minus 4t, y is equal to 1 plus t, and z is equal to 1 over 2 plus 5t. And line 2 consists of x is equal to 3s, y is equal to negative 2 minus s, and z is equal to 4 minus 2s. Right now, you have to show that whether two lines parallel to each other. So in this case, you have to compare in terms of the vector parallel to the line. So in this case, vector, okay, right now let me write it one by one, such as we're going to discuss about the solution to this question B. You have to show that line L1 parallel to line L2. In order to show two lines parallel to each other, you have to compare in terms of the vector parallel to each line. So in this case, vector parallel to L1 is negative 4, 1, and 5. Vector parallel to L2 is equal to 3, negative 1, and negative 2. So right now, what should you do? You have to show this expression is true, such as VL1 is equal to K VL2. So in this case, I will get negative 4, 1, 5 equal to K 3, negative 1, negative 2. So I have to compare in terms of components separately. Alright, negative 4 is equal to 3k1. That represent the first component, which is ith component of the vector, I will get k1 is equal to negative 4 over 3. 1 is equal to negative k2, k2 is equal to negative 1. And 5 is equal to negative 2 k3, k3 is equal to negative 5 over 2. Since there is no unique k such that k1 is not equal to k2 is not equal to k3, therefore L1 is not parallel to L2. So you are able to show that line L1 is not parallel to line L2 since there is no unique k such that k1 is not equal to k2 is not equal to k3. So if the lines are parallel to each other, you should get the same value for k throughout the components. So since you are able to show that two lines are not parallel to each other, so you have to show either the lines intersect or skew. In order to show that lines is skewed to each other, you have to show that the two lines neither parallel nor intersect. So right now, we want to show that the two lines intersect with each other. So, show line L1 intersects line L2. So right now, what should you do? You have to remember, in order for two lines to intersect with each other, they have to share the same common point, which is at some point they will share the same x coordinate, y coordinate, and z coordinate. So I'm going to compare in terms of coordinate, such as x with x, y from L1 with y coordinate of line L2, and z coordinate of line 1 and z coordinate of line 2. So in this case, I will get x consists of 2 negative 4t equal to 3s, y 1 plus t equal to negative 2 minus s, and z is 1 over 2 plus 5t equal to 4 minus 2s. As you can see from these three expressions, you have two unknowns such as unknown t and unknown s. So right now, in order to determine unique value of these two unknowns, you have to at least find two equations since you have two unknowns. So we will going to call it as first, second, and third equations. So you can either choose to solve the first two equation, or solve 2, 3 equation, or solve 1, 3 equations simultaneously in order to determine the value of both unknowns. So in this case, maybe I can choose solve 1 and 2 simultaneously. Okay, I will get from 1 negative 4t minus 3s equal to negative 2. So I'm trying to rearrange the equation 1 where I will put all variables at one side, which is at my left hand side. Meanwhile, constant I will put on the right hand side. So from 2, I will get t plus s equal to negative 3. So I'm going to call this as 4 and 5. Okay. By using your calculator, when you try to key in the information, for solving two unknowns, you will get like what I have provided in the slide presentation, such as t is equal to 11 and s equal to negative 14. So what should you do with these two value of these two unknowns? So you have to substitute back into equation you still not use in the original equation, such as you put into substitute t and s into equation 3. Okay, if you are able to show that left hand side is equal to right hand side when you substitute the value of t and s, you can safely say that the two lines are intersect with each other. But if that is not the case, then you can conclude that these two equations or these two lines are not intersect with each other. If that happens, since you are able to show that the lines are not parallel to each other, are not intersect with each other, therefore they are skewed to each other. So in this case, when you substitute the value of t and s into equation of 3, you will get 27 is not equal to 7 over 2. So left hand side is not equal to right hand side, which is false equation. By having this conclusion, since L1 is not parallel to L2 and L1 does not intersect with L2, therefore L1 is skewed to L2. So that is your conclusion when it comes to this question. But I would like to ask your attention in solving question C, where the question C will show you where two lines are intersect with each other. When two lines intersect with each other, you have to show or you have to determine point of intersection between line L1 and line L2. I hope you can do this question on your own. If you have any problem with the question, please don't hesitate to contact me from time to time. I'm more than happy to help. I think until then, see you again in the next video. Bye.